Welcome back to WikiNarrator. On the morning of June 30th, 1908, in the remote taiga of Siberia, something extraordinary happened. Without warning, a massive explosion ripped through the sky above the Podkamennaya Tunguska River. There was no crater, no meteor fragments to dig up, yet when scientists finally reached the site, millions of trees lay flattened in a radial pattern over more than 2,000 square kilometers, an explosion more powerful than any ever witnessed in the modern era. This was the Tunguska Event, an explosion so mysterious that even today, more than a century later, experts still debate exactly what caused it. It was shortly before 7:15 a.m. on June 30th, 1908, when watchers in the sparse settlements of eastern Siberia saw it. A brilliant fireball streaking across the sky, brighter than the sun at times, trailing smoke and moving at unimaginable speed. Eyewitness accounts from Evenki reindeer herders and Russian settlers describe an enormous flash, followed by powerful shockwaves that rattled the earth and cracked windows hundreds of miles away. Some compared the thunderous sounds to distant artillery or a colossal explosion in the heavens. But then, silence. When the blast wave faded, the land itself was transformed. Trees lay smashed and scorched, not in the random topple of wind or storm, but in a pattern that radiated outward like spokes from a hub. Because the event occurred in such a remote region, literally the depths of Siberian wilderness, it took nearly 2 decades before scientists could seriously investigate. In 1927, Russian mineralogist Leonid Kulik led the first expedition to the site under the auspices of the Soviet Academy of Sciences. When he saw the flattened forests and scorch marks, he was stunned. Yet even Kulik's team found no impact crater and no obvious nemesis. No great metallic fragments, no blasted rock, nothing that looked like a conventional asteroid strike. Nature had erased the culprit. Scientists estimate the explosion released energy equivalent to 10 to 15 megatons of TNT, a blast roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima. Its shockwaves were recorded by barometers around the world. But unlike Hiroshima, the source was not a weapon, nor did anything strike the ground. Instead, the leading idea became the airburst theory. The notion that an incoming space object exploded high in the atmosphere, releasing its energy before ever making contact with Earth. Where meteors typically leave behind craters or fragments, none were found here. The blast occurred at an altitude likely between 5 and 10 kilometers above the surface, scattering energy in a blast wave that leveled forests across the region bigger than many major cities. The most widely accepted explanation is that a cosmic object, a medium-sized asteroid or comet fragment tens of meters across, entered Earth's atmosphere at hypersonic speed. As it descended, atmospheric pressure and friction caused it to heat, fragment, and ultimately explode in the midair. This kind of event, known as an airburst, is now familiar from smaller modern examples, like the 2013 Chelyabinsk meteor, which exploded over Russia with a much lower energy but still caused injuries and shockwaves. But Tunguska was far more powerful, capable of leveling thousands of square kilometers. If the explosion had occurred over a major city instead of the Siberian wilderness, the devastation would have been enormous and historic. Despite the airburst theory's acceptance, some questions linger. No identifiable crater exists. No large fragments of the object have ever been conclusively recovered. Some researchers have pointed to unusual chemical signatures in soil and tree resin that suggest extraterrestrial material, but evidence remains sparse. There have even been fringe explanations over the years, from gas explosions deep within the Earth to unknown exotic cosmic bodies, but nothing has gained substantive support in the scientific community. Interestingly, one potential clue lies in Lake Cheko, a small round lake near the blast area. Some researchers once speculated it might be an impact scar, but later geological studies suggest the lake predates the event. Its shape and sediments have fueled debate, but it's far from a smoking gun. Though Siberia was sparsely populated, the shockwave from the explosion was felt around the globe. Seismic instruments recorded waves from the blast, and atmospheric effects, like unusually bright skies, were reported as far as Europe for days afterward. The Tunguska event remains the largest impact event in modern history for which we have direct observational reports and scientific study. It sits alongside events like Chelyabinsk on the spectrum of cosmic threats, but stands apart for its sheer scale and mysterious absence of physical remains. Today, planetary defense scientists use Tunguska as a case study, a stark reminder that even relatively small cosmic objects can unleash destructive force if they intersect Earth's path. Modern efforts to monitor near-Earth objects and develop deflection strategies are, in part, inspired by the lessons of this remote sky explosion. So what caused the Tunguska blast? Most evidence points to a meteor airburst. a cosmic visitor that disintegrated high above the taiga. But the absence of definitive fragments and the peculiar details of the explosion ensure that some mystery will always remain. In a quiet stretch of forest, the trees still whisper of that day in 1908, a reminder that earth and sky are in a constant, fragile conversation, and that even in a remote wilderness, the universe can reach down and make itself felt. Thanks for watching this episode of WikiNarrator. Feel free to like and subscribe, and please comment with any other ideas.